For the last year or so, there's been this ghost story kind of circulating in Silicon Valley. It's whispered in boardrooms, debated in research labs, and it's honestly keeping some very smart people awake at night.
Oh, yeah.
They call it the data wall.
The data wall.
Yeah.
It sounds ominous, doesn't it? Like something straight out of a sci-fi novel.
It really does.
But honestly, for a while there, I mean, it really looked like it was going to be the end of the line for the rapid AI progress we've all gotten so used to.
Right, because the logic has always been super simple. If you want to make the model smarter, you just feed it more text.
Exactly.
You feed it the entire internet, every book in the Library of Congress, every scientific paper, every Reddit thread ever written. But the problem is...
We're finished. We read it all.
Yeah. We are effectively tapping out the reservoir of high-quality human text. That is just a fact now.
It is. We've digitized pretty much everything worth reading, and these models have consumed it.
So, the question becomes, if you can't make the model smarter by giving it more to read, what do? Do we just stall out?
That's the fear. But today, we are diving into a technical report that claims to have found a ladder over that wall.
A ladder over the wall. I like that.
Yeah. We're looking at the Kimi k1.5 model. And the headline here isn't just, we made a bigger model. It's that they've figured out how to make a model smarter without needing more human data.
Which is just a massive shift.
That's a complete paradigm shift. They're pivoting from, learning by reading to learning by doing.
Okay, so our mission for this deep dive is to unpack this report from the Kimi team. We need to understand how they are matching the reasoning power of giants like OpenAI's o1. But, and this is the part that really surprised me, they're doing it with a framework they actually describe as simplistic.
Simplistic is the exact word they use. And when you look at the architecture, it's shocking how much standard engineering they actually just threw out to make this work.
So let's start right there. Segment 1, the core innovation. Why is everyone else hitting this wall? And why does Kimi think they can just walk right through it?
Well, to understand the solution, you kind of have to understand the trap everyone is currently in. The standard way we train large language models, the way GPT-4 or Claude were originally trained, is called pre-training.
Right.
It's effectively next token prediction.
Which is basically fancy autocorrect, right?
Extremely sophisticated autocorrect, yes. The model looks at a sentence like, the cat sat on the... and it guesses mat.
And if it guesses car, you correct it.
Exactly. But the limitation here is that the model can only be as smart as the text it is training on. It is mimicking human intelligence. It's not generating new intelligence.
Yes, it's a parrot. A very, very smart parrot with a photographic memory, but it's not solving problems it hasn't seen before. It's just recalling patterns.
Precisely. So Kimi k1.5 pivots to scaling reinforcement learning, or RL. Now, RL isn't new. We used it to teach AI to play chess and Go.
Right, AlphaGo and all that.
Yeah, but using it as the primary engine for general reasoning scaling, that is the breakthrough here. Instead of showing the model a textbook and saying, memorize this, you give the model a problem and say, figure it out.
Okay, but wait. How does it figure it out if it hasn't read the textbook on how to solve it?
Think of it like a video game.
Okay.
In pre-training, the AI watches 1 million hours of a pro gamer playing Elden Ring. It knows what it looks like to win, but it's never actually touched the buttons.
Right.
In reinforcement learning, you give the AI the controller.
And it immediately runs off a cliff.
It dies instantly, repeatedly. But, and this is the key, it gets a signal that says, that was bad. So it respawns.
It tries jumping.
Right, it tries dodging.
Yeah.
Eventually, through millions of trials, it discovers strategies that maybe even the human players didn't know. It learns to explore.
So it's generating its own experience, and this is how they beat the data wall.
Yes. Because the model isn't waiting for a human to write a new physics paper to learn physics. The model is running its own simulations, generating its own trajectories, and learning from its own successes and failures. It scales its training data internally.
That sounds incredible, but you mentioned earlier that the Kimi team called their approach simplistic. And I know for a fact that other labs, when they try to do this reasoning stuff, they use very heavy machinery, things like Monte Carlo tree search.
Yeah, MCTS.
Yeah.
That's where the AI maps out a giant decision tree of every possible move, sort of like a chess computer.
Yeah, branching out.
Exactly. It branches out like, if I do A, then B happens, but if I do C, and so on. And usually you pair that with a value function, which is a separate AI critic that judges every single step.
Good step, bad step, mediocre step.
Yeah. It's very rigid, very engineered.
It sounds like micromanagement.
It totally is.
Yeah.
It's micromanaging the AI's thought process.
Yeah.
Kimi k1.5 completely avoids that.
Wait, no search tree. No step-by-step critic model at all.
None of that. They rely on long context scaling. They push the context window, the model's short-term working memory, up to 128,000 tokens.
128K tokens. That's what, like a thick novel?
It's huge. It's like giving a student a generic notepad that is 500 pages long. And their theory, which seems to be proving correct, is that if you give the model enough blank paper and you train it with reinforcement learning, it naturally develops the planning structures itself.
So it literally invents its own way of organizing thoughts.
Exactly. It doesn't need a human to code a tree search algorithm into it. It learns to backtrack, to double-check, to verify its own assumptions, and to decompose problems just because that's what gets the reward.
That's actually really profound. It implies that reasoning isn't an algorithm you have to install. It's an emergent behavior if you just give the brain enough room to think.
Room to think is the perfect phrase. And that leads us directly to how it uses that room, which brings us to segment 2, long chain of thought.
Chain of thought is a term we hear a lot. Usually it just means telling the AI in the prompt, hey, think step by step, right?
In the prompt, sure. But here we're talking about the training process itself. Imagine you're grading a math student.
Okay.
If they just write 42, you have no idea if they actually know math or if they just guessed or if they cheated. Kimi forces the model to show its work, every single step.
But with a 128K context window, that's a lot of showing your work.
It is. And this is where the engineering gets tricky. The Kimi team found that when you scale RL, the reasoning chains can get massive. We're talking thousands of steps of thinking before it even writes the first word of the answer.
Wow.
Yeah, and if the model had to restart from the beginning every time it made a mistake, training would take a century.
Well, yeah, because if you're on step 900 and you mess up, you don't want to redo steps 1 through 899. That's just wasted energy.
Exactly. So they use partial rollouts. Because the memory context is so deep, they can effectively create save points.
Like in a video game.
It's exactly like a save point. The model can think down a path for 10 minutes, hit a dead end, realize it made a wrong assumption, and the system can seamlessly rewind it to a previous checkpoint in the thought process and say, okay, try a different branch from here.
That's wildly efficient. It's like being able to rewind time in an argument when you realize you're wrong.
We could definitely all use that feature.
Totally.
But there was a funny side effect to this freedom. During training, the researchers discovered the model started overthinking.
Overthinking, like it was anxious.
In a way, yeah. Because the model wants the reward. It desperately wants to get the answer right. It started making its responses incredibly long just to be safe.
Oh, I see.
It would double-check, triple-check, go down rabbit holes, rederive basic formulas, just to ensure it didn't miss a single thing.
I do that. I write a 3-paragraph email when a yes would suffice because I don't want to be misunderstood.
And just like with your email, that's inefficient. It wastes tokens, it wastes time. So the Kimi team introduced a length penalty.
A penalty. But wait, I thought we wanted long context.
We want necessary context. The mechanic is brilliant. If the answer is wrong, the model gets penalized, obviously.
Sure.
But if the answer is correct, the size of your reward depends on how concise you were.
Ah, I see. So the instruction is basically, get it right, but don't waste my time.
Exactly. It forces autonomy of thought.
Yeah.
It teaches the model that brevity is also a virtue, but only after accuracy is secured. It forces the model to become efficient at thinking, not just accurate.
That seems like a really delicate balance, because if you penalize length too much, it stops thinking deeply.
Right.
But if you don't penalize enough, it rambles.
It's a tightrope walk. But the architecture is only half the battle. You can have the best brain in the world, but if you study from bad textbooks or if you practice on questions that are too easy, you learn nothing.
Right. Garbage in, garbage out, the oldest rule in computing.
It's the golden rule.
Yeah.
But for reinforcement learning, it's garbage prompt, garbage trajectory. The Kimi team emphasizes that prompt curation, the quality of the questions they ask the model to solve, is more important than quantity.
Makes sense.
But they ran into a classic AI villain here, reward hacking.
Oh, I love reward hacking stories. This is where the AI basically cheats, right?
It's where the AI follows the letter of the law, but violates the spirit. For example, if you give it a multiple choice question, the model might learn that C is statistically the most common answer in the data set.
So it doesn't learn physics, it just learns to guess C.
Totally. It's gaming the test. It's not learning the material, it's learning the test format.
So what did they do?
Kimi took a sledgehammer to the data set. They removed all multiple choice questions. They removed all true or false questions. They removed anything where you could guess the answer without doing the actual work.
Wow. So every question requires an open-ended generated solution.
Yes. But they went even further. They implemented something called the N8 rule to filter out easy questions.
N8, what does that stand for?
So N is the number of attempts. They took a standard non-reasoning model, we'll call it a dumb model, and gave it the training questions. They let it just guess without any chain of thought, just shooting from the hip. If that basic model could get the answer right within 8 tries, Kimi threw the question in the trash.
That is harsh. So basically, if a distinctively average bot can guess this, it's not worthy of Kimi k1.5.
Exactly. They deemed those questions too easy or hackable. They wanted to ensure the model was only training on problems that required deep reasoning to solve. It's like training for a marathon and refusing to run on anything but steep hills.
That makes total sense. But once the model generates these complex answers to these incredibly hard questions, who grades them? You can't have a human check millions of AI answers.
That is the big bottleneck. For coding, it's pretty straightforward. They built a sandbox using a tool called CRON.
Right.
You run the code the AI wrote. If it compiles and passes the test cases, it works. It's binary.
True, code either works or it doesn't, but math is trickier. You can arrive at the right number via the wrong math.
Which is a disaster for training because you're reinforcing bad logic. The Kimi team found that a classic reward model one that just looks at the final answer was only about 84% accurate. Yeah, that means 16% of the time it was giving the model bad feedback.
That's way too high for a training run. You'd poison the model with bad habits.
So they built a chain of thought reward model. This is an AI grader that doesn't just look at the solution, it actually reads the reasoning steps.
Oh, nice.
By doing that, they bumped the grading accuracy to 98.5%.
So you have a smart teacher grading the smart student.
It's the only way to close the loop. You need a feedback mechanism that is as sophisticated as the model you're trying to build.
Okay, so let's pause and look at what we've built here. We have a model with a massive memory that explores solutions, learns from its mistakes, gets penalized for rambling, and is trained only on the hardest problems with a strict grader.
That's the Kimi k1.5 recipe.
But here's my issue. As a user, I don't really care about the recipe. I care that when I ask a model a question, I don't want to wait 45 seconds while it thinks through 12,000 tokens.
Fair.
That's expensive, it's slow, and frankly, it's annoying for simple tasks.
You are hitting on the practicality gap. Long chain of thought is amazing for solving cancer research or complex coding, but it is terrible for write me an email to my boss.
Right.
This is why segment 4 of their report, Long Too Short, is arguably the most commercially important part.
Long too short. Is it exactly what it sounds like?
Ideally, yes. The goal is to transfer the genius reasoning patterns of the long, slow model into a shorter, faster model. They want the genius without the wait time.
How do you compress intelligence? You can't just unzip the files.
Not quite. They use 2 main techniques. The first is model merging.
Which sounds like sci-fi.
It's surprisingly literal math. They take the weights, the numerical parameters of the long thinking model and the short model, and they basically average them in vector space.
No, you can just average the brains, and it doesn't turn into mush.
In a high-dimensional space, it actually works. It aligns the capabilities. But the second technique, shortest rejection sampling, is even more intuitive. Remember how we said the model generates many solutions?
But exploring different paths.
Well, imagine the model solves a math problem 10 times. One solution takes 100 steps. One takes 50, one takes 20, but they all get the right answer.
Okay, I see where this is going.
To train the short model, they throw away the long ones. They take that 20-step solution, the most efficient crystallized version of the thought process, and say, here, small model, learn this.
Oh, that is clever. So they are cherry-picking the moments of brilliance where the model was concise and using that as the textbook.
Exactly. They are distilling the efficiency. And the results are actually staggering.
Yeah.
The Kimi k1.5 shortcut model, the fast one outperformed GPT-4o and Claude 3.5 Sonnet on major benchmarks.
Wait, it beat GPT-4o.
In specific reasoning tasks, yes. On the AIM Math benchmark, it scored a 77.5. On Math 500, it hit 96.2. They report a 550% improvement over existing short-chain models.
That's massive. And this is the model that doesn't take 45 seconds to answer.
Correct. It matches the reasoning power of OpenAI's heavy O1 model, but in a package that feels like a normal chatbot.
That is the holy grail. High IQ, low latency.
And low cost. That's the kicker. The less compute you use to get the answer, the cheaper it is for everyone.
But none of this happens without the hardware to run it. We have to touch on segment 5, the infrastructure. I know talking about infrastructure usually makes people tune out, but the report makes a really big deal about this.
Because it's the bottleneck breaker. You cannot train these models efficiently with standard setups. The Kimi team uses a hybrid deployment.
Explain that to me.
Typically, in an AI lab, you have a cluster of GPUs doing training, which is learning, and a separate cluster doing inference, which is generating text. They are separate worlds, separate machines.
Sure.
But in reinforcement learning, the model has to do both constantly. It has to generate a thought, get graded, and then update its brain. If you have to move data between different machines for every single step, the latency just kills you.
It's like trying to cook dinner, but your fridge is in the neighbor's house. You spend more time walking than cooking.
Perfect analogy. So Kimi runs both on the same GPUs. But that creates a memory problem. Training eats memory, inference eats memory. To make this work, they built a checkpoint engine.
What does that do?
It allows them to switch a GPU from learning mode to answering mode in less than a minute.
Less than a minute. I thought swapping these massive models out of VRAM took forever.
Usually it does. That's the engineering marvel here. And it enables that partial rollout we talked about earlier. They can pause a thought, offload it, switch the GPU to train on something else, and then reload the thought later.
So nothing sits idle.
Nothing. It maximizes the utility of every transistor. It prevents one really hard, long question from clogging up the whole factory.
So when we zoom out, we're looking at a system that effectively generates its own training data. It filters that data so it's only learning from the hard stuff. It cleans up its own thinking process to be efficient. And then it compresses all that into a fast model.
That is the Kimi k1.5 story. And I think the real headline here is that simplistic approach.
Right, that it didn't take a complex new architecture.
It proves you don't need to reinvent the wheel. You don't need value functions or tree search. You just need to give the AI room to think, that 128K context, and a system that rewards the process, not just the answer.
It really circles back to the data wall. If this works, if models can truly learn by exploring rather than just reading,
And the limit isn't human data anymore. The limit is just how much compute you can afford to burn.
that's a shift in the fundamental economics of AI. We're moving from a scarcity of text running out of books to a scarcity of electricity and chips.
A fascinating and slightly terrifying trade-off. But it suggests that the stalling out of AI progress was a temporary hurdle, not a permanent wall.
Well, it makes you wonder about the next step.
How so?
If these models are now generating their own training data and deciding the most efficient way to think entirely without human oversight, at what point does their internal logic become totally alien to us?
Oh, that's a good point.
Yeah, we might get fast, cheap answers, but we might completely lose the ability to comprehend how the AI actually got there, simply because its thoughts are optimized for machine efficiency, not human readability.
The black box just gets darker.
Exactly. Well, on that slightly terrifying, slightly hopeful note, we're going to wrap up this deep dive into Kimi K1.5. A massive thank you to you for breaking it all down.
It was a pleasure. Transparency like this from the Kimi team is rare these days, so it's great to dig into.
It really is. And to you listening, pay attention to this long to short trend. We might be seeing a lot more smart but fast models landing on our devices very soon.
The wait times are dropping, but the IQ is going up.
Couldn't have said it better. Stay curious, stay skeptical, and we'll catch you on the next deep dive.